All right, here visiting Renishaw booth, and so of course, we use robotics to pair with CNC machines, and we've got drawer systems to feed the robot to feed the machine. But then the question is, okay, all these parts are getting produced, but how do we know that they're good? How do we know that they're the right parts, that they were machined correctly, and if they weren't, is there a way to automatically offset them? Enter Renishaw. And so I've got Scotty. I'm joined with Scotty. He's the technical training manager with Renishaw, and they've got a variety of products here that we're going to look at that take us through that check part verification, and then also helping us to make those offsets. So with that, Scotty, take us through from the beginning of what you guys are trying to attack. What kind of solution?
So the big thing that Renishaw lives, breathes, and eats is right here is the productive pyramid. So everything that Renishaw does in their production process is every month they produce over 1 million parts. So the first thing they do is right here is the preventive part. So the preventive is going to be using lasers and ball bar to calibrate the machines to make sure the machines are repeatable. If a machine's repeatable, then you pull the accuracy in. Then once you get your accuracy, then you can do your reproducibility. So first we validate the health of the machine, make sure it's accurate and repeatable. Then the next thing we do is process setting. The process setting is going to be with our machine tool probes and tool setters. So once your machine's calibrated, then you calibrate your probe and your tool setters. And then during that, if you want to, you can inspect the parts with the probe in the machine, because you do know the machine's health is good, and you know that what it's going to give you is good data out of that. But we also have this overlap between these two, that we have the equator, and we'll show you these products as we go through. But the equator can set outside, or does set outside the machine. The equator can also communicate to a robot, and the equator can also communicate to your CNC machines. So we can do the offsets to the CNC machine. It can also tell the robot if the part's good or bad. So then you can sort into a green box or red box if you want, or any of the above. And then our last one is post-process monitoring, which is a CMM, and we have a 5-axis CMM. We've had other people that are with the 5-axis that can be parallel, perpendicular to any feature. So the speed of that, and we can change the heads out, so we can do surface finish. We can also do ultrasonic, where we can just measure from one side to get a wall thickness. We can also have a vision system, and all of that changes out on the same head. So we've had in aerospace people that are having 3-hour inspections. They did it with our 5-axis CMM, and we can do it in 28 minutes, hands down. So we'll show you the products here, and we'll just start with calibration. So with this here, this is a ball bar. So what a ball bar does is any calibration that you're doing, you need to have that to what's holding your work and to what's cutting your work, because mathematically that's what matters in your production process, is what's cutting your work and what's holding your work. And then those positions mathematically, how are they repeating and how accurate are they to stay in where they're supposed to be. So what the ball bar does is just look at it as an electronic indicator. This will swing around in the XY axis, and then this will also do the ZX axis and then the YZ axis. So a lot of people don't realize that for every machine, you got 6 degrees of freedom per axis. So if you got a 3-axis mill, you got 6 ways that can be out on the X, 6 in Y, and 6 in Z. So that's 18 ways the machine can be out. Then the ball bar checks the XY, the ZX, and the YZ. So just a basic 3-axis machine is 21 ways that it can be out. So this is where we would do the productive pyramid and controlling the process of getting the health of the machine correct.
And just real quick, so as he explained, Scotty explained to me before, basically this piece would be on the base of the work, where the work's happening. This actually goes into the spindle, and then that way
so you're showing the relationship between where you're cutting your work and then what tool is cutting your work.
Yep.
So on a mill, you need to be either attached to a table or a fixture that's attached to the table, and something in the spindle. And then if you're on a lathe, you got to have something in the turret and something to the chuck. then we step into the second part, which is process setting, and that's with these Renishaw probes. So what the probe is a probe is not accurate at all. What a probe is repeatable. So if I trigger this comes back to the exact same spot every time within a quarter of a micron. So we're talking 10 millionths of an inch with this particular probe. So every time it triggers, it just comes back to the same spot. So the thing to keep in mind is when the probe triggers, it freezes the position the machine thinks it's at. But if you calibrated your machines, you know they're going to the right spot now. So then you can do inspection with the probe on the machine after you calibrate it. And then we have different tool setters. We have a touch tool setter where we can touch here and get the diameter of the tool, but we can also use this plunger to touch, or we have lasers that we can go through here, or they can span all the way across. So we can do break detection. We can come in and just touch before it goes in, any of the above, to help control your process.
All right.
And then the other one, which is going to be an in-process control. So this is the equator. This is the one that we were talking about. So if you look over here, here's the quality checks that this is going through. But the equator can communicate to a robot, and the equator can communicate to your CNC machine. So when this runs, we'll work with the company to know which tools do what, and then as it checks that feature, it'll offset that tool to whatever the customer wants to do. So typically, most want to do 10% or 70% the nominal. So say it was out by 10 thousandths, it would offset that tool by 7. The next part would come out, it'd be off by 3. The next part would come out, would be off by 1. And then as you see this, all of your quality checks here, you'll start seeing it get into nominal, and then it just stays. So the equator is set up to live on the production floor, be out on the production floor, and to work with the CNC machines and with the robots together. But the whole purpose of all of this is metrology. Metrology is the science of measurement. So everything that we're doing at Renishaw is measuring parts. And then here, we have fixtures here, but we also do metal printing. So that was a metal printed part. And then these are different heads that can go onto the CNC machine or CMM machines. So then with the head there, that follows the very top of the pyramid of post-process monitoring, and you validate everything with the CMM as it comes out of that.
It's incredible how fast these are these days.
Yep,
I mean,
the
that
speed
is
of
just,
this. Yep.
it's insane that it can be checking it that quickly.
And this is the same thing that we were talking about with a company that had a 3-hour inspection, and then we came in with them and we did it in 28 minutes.
Sure.
So our whole purpose is to help you control your process and to increase your throughput of your products.
Fantastic. Well, Scotty, thank you so much. Appreciate the whole rundown.
Thank you.